Okay. All right, friends, so let's talk about your calculus survival guide, which is the binder with the dividers and all the things in the right order. It's coming with you to class every single day. This is the most important thing I could give you to help guide your review process and keep you organized. At no point are there going to be APES things in here, or AP English things in here, or AP Physics things in here. This is your calculus survival guide. Now it's yours, so feel free to decorate it any way that you want. First year I did this. There was a group of 4. One of them had an Iron Man stickers all over it. Another one was Thor. Another one was the Hulk. Another one was Captain America. Whenever they got together, they'd be like, "Avengers Assemble!" And make it your own. Whatever nerdy thing you want to do, feel free. Feel free. Of course, we had then the Powerpuff Girls as well. That worked too. Whatever you want to do, feel free. This is yours. But it comes to this class every single day. Now here's why I want you to have the dividers, and I want them numbered. You're going to number them according to the, You're going to number them according to the cover sheet. So when I say, hey, go to section number 9, what am I going to find in section number 9?
BC Survival.
The BC Survival Guide. You all do not yet have the BC Survival Guide because you're not in Calculus BC. However, any of you that are pretty sure you're majoring in math, science, or in engineering that is going to require you to take Calculus 2, just send me an email and say, can you please get me a copy of the BC Survival Guide? Because that's like another 30 pages of stuff that you're going to want access to. Okay? Section number 12, what goes in there?
Graded work.
Graded work. Okay, section number 15?
Ti-Nspire calculator.
Ti-Nspire calculator instructions. Now, a lot of you guys have the tabs. That's great. Numbering them is going to help, because when I say go to tab number 17, I don't want days being like 1, 2, 3, 4. Number them, label them, so that it is quick access. I do have a Sharpie. I can loan it to you if necessary. Now, the other thing, and this was a labor of love a couple of years ago while I tried to watch White Chicks. What a horrible, horrible movie. I stopped. I stopped when she had dinner with the guy and he started chewing his toenails at the table. I had to stop. Feet. Okay. Section 10 is the index. This thing took hours to put together. Hours and hours and hours, because I know I think about this course in terms of units, and if you said, hey, what were we doing in section 4, I could rattle off all the things. I don't expect that you can. So, section 10, everybody go to section 10, please. This is the index. And we're going to do this rapid fire. Okay, I want to make sure that you know how to do this. Let's say you need to find L'Hôpital's rule. L'Hôpital's rule. Where in your agenda, your survival guide, are you going to find L'Hôpital's rule?
Unit 4, page 3.
Unit 4, page 3 is where L'Hôpital's rule is. Okay, what if you need to find the derivative of the arctangent function? Derivative of the arctangent function. It's what? Unit 3, page 4. So you would go to Unit 3, page 4, and you can find the derivative of the arctan function, okay? I would make sure that you understand how to use the index, right? It's just like the index in the back of the book, but this is specific to your survival guide, and this is why I want you to have the tabbed dividers. Okay? What questions are out there about the survival guide? Destiny.
Are other things going in the numbers, like you just say like next week we go, we're unit 1, are we getting other more pages in here?
You're not going to get more pages for any of the particular units. However, there are things, there's another special topic bundle, it's like another 40 or 50 pages, just like the unit guides that we've used all along, and that's going to go in section 11. Any graded work that I give you is going to go in section number 12. Okay? Everything is going to have a place, just like it ought to be. Okay, now, this is going to take a couple of minutes, so bear with me while we do this. There are some places I want to call particular attention to in your survival guide. Okay, so depending on how you want to do this, you might want to put like a little tabby, because these are going to be places you're going to want to go to a lot this week as you get ready for the common assessment. I have extra post-it notes if anybody wants some extra post-it notes. I'll just put them out at the table. I do try. Okay. 4, 5, 6. All right, I'm going to tell you really important places in the survival guide. So here we go. In section number 1, find page 7, please. Okay, section 1, page 7. What are we finding here? Important things I want you to pay attention to in section 1, page 7. Maybe you want to highlight these things. Maybe you want to put a little flag there. Continuity, the process for showing that a function is continuous, should be in section 1, page 7. And the process for using the intermediate value theorem. These are going to be important things on the common assessment on Thursday. You're going to want to spend some time. Make sure that you're really good there. Okay, in section 2, please find pages 4 and 5. Pages 4 and 5, this is all that F, F prime, F double prime relationship. Points of inflection, concavity, right? The session that I facilitated at the AP Summit on Saturday. This is 20% of your exam on Thursday, has to do with F, F prime, F double prime relationships. You have to know them. You have to know them all, and you have to know them well. In section 3, go over to section 3, please. Find pages 3 and 4. These are all the derivative rules. You have to know them all. I would maybe start thinking about making flashcards, or finding your old flashcards, or finding that derivative foldable. So pages 3 and 4, you need to know all the derivative rules. For example, the derivative of secant of x is...
Tangent of x.
Really?
No.
I have a misprint. You should find derivative of secant of x in this table, please. It's secant of x times the tangent of x. I don't want you to have to derive that in the middle of the test. I want you to know that and know it cold. Okay, so Diego, now you're setting 15-minute reminders.
Diego.
Gonzalo. Okay. Section 4. Let's go ahead to section 4. We need to move this along. Okay, pages 3, 4, and 5. In section 4, it's pages 3, 4, and 5. This is where you're going to find L'Hopital's rule. There's a L'Hopital's rule question on Thursday. The mean value theorem and the extreme value theorem. So that was section 4, pages 3, 4, and 5. In section 5, page 5 has the fundamental theorem of calculus. Anything that is named is important. Okay, on page 6, there's some physics stuff about displacement versus total distance traveled. You want to make sure you're not getting confused with those. Okay, let's go on to section 6, pages 4 and 5. We're almost there. Section 6, pages 4 and 5, these are all the integration formulas that you knew at one point in your life. You have to commit to memorizing these things. I'm not usually Mr. Memorize, 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 but in the middle of the test on Thursday, you don't want to be like, oh gosh, what was that? You want to know it cold. Okay? Other things in section 6. If you have forgotten how to do integration by substitution, there's a worked out example on page 6. The second fundamental theorem of calculus, we also looked at that on Saturday. That's the derivative of the integral of a function and how things cancel out. That is pages 6 and 7.
3 and 6.
Yep. All right, section 7, page 3, separable differential equations. We spent a good amount of time here. You guys got really, really good with separable differential equations. There is going to be a separable differential equation on Thursday. I want you to be ready for it. Okay, in section 8, this is the unit that we just tested on. I'll be giving you the unit test back tomorrow once I have Andy, Gonzalo, and Avel's tests graded. Pages 5 and 6 has all those integral setups for volume of revolution. The hollow object, the solid object. You spin around an x-axis, you spin around the y-axis. Those should be really comfortable. And then pages 7 and 8 has all the integral setups when you work with your cross-sections. And that's it. Those are the big things. Those are the really big things. Questions about the survival guide? Yep.
Are you gonna give us practice and then we're gonna put them right here by units?
Say that one more time.
Are you gonna give us practice and then we're gonna put it by units?
There is going to be a different practice section. That's that special topics thing I mentioned earlier. That has its own section that it's going to go in. And each section has links to videos, God bless. So if you find, like when we're going over integration by substitution, I'm going too fast, you're just not able to keep up, or you're working on the homework and you're like, gosh, I just don't remember, the video's right there that you can go to. All right, so with that said, we're done with the survival guide. Let me pass out, I think, Julissa, did I take your index? Not index, but cover sheet. Okay, here's the homework for the next 3 nights. 4, 7, 9, 12, 16, 20. Okay.
Mr. D, this was a special topic?
Let's put that in graded work. That's a good question. Yes?
If like the hurricane and all that stuff wouldn't happen, would we have started this earlier?
If the hurricane hadn't happened, would we have started this early? Possibly. There are also some things that we didn't spend as much time on as I wanted to. And so there are some places where I compacted things a little bit more than I wanted to. We would have ended at roughly the same place at the same time. We just lost some practice days along the way and some other activities that I like to do. Okay, everybody good? All right, so let me explain the homework this week. Your homework this week, every night, is going to be to work through a free response question from start to finish, completely on your own, no help from anybody. If you want to use your survival guide, that's okay, but I'm also interested to see just how well do you remember the things that we've done. You're going to do that for 15 minutes. Tonight you're going to do question number 2. So make sure that that's clear. You're doing question number 2. Question number 2 is calculator active. When you are done working through question number 2, that's this guy here, I need you then to watch the video. I filmed all the videos over spring break, because, you know, why not? What else are you going to do? So there are, I did 18 videos over spring break, 12 for Calc AB, 6 for Calc BC, working on the next 6 for BC this week. So you're going to work through question number 2 completely on your own for 15 minutes on a separate sheet of paper. You're going to do well on some questions, you're going to not do so well in some other parts of this question, and that's okay. Then, just like we did before the fall common assessment, you're going to watch the video, you're going to take notes, you're going to give yourself some feedback, and then just let you know, like, hey, how many points did I earn? I earned 5 out of 9, I earned 6 out of 9. I want you to record that on there. Tomorrow, you're going to turn that into me. Done, that's tonight's homework. In total, it should take you about 35 minutes. I don't see how you could do it in less than 35 minutes, but it shouldn't take more than 35 minutes either. 15 minutes to do the question, 15 minutes to watch the video, a couple minutes to give yourself some feedback. Yep, Rebecca.
So is it how, they're gonna take up grades like for homework, it's like the,
Basically, you're completing this assignment in the way that I'm asking you to do it, gets you a 100. Okay? So today we're going to do one in class, you'll do one for homework. Tomorrow we're going to do multiple choice practice in class, plus one free response. We'll do one for homework. Wednesday, it's a long day. This is not early release Wednesday this week. So we'll do another practice multiple choice, one free response, and then you'll do 2 free response that night that are turned in on Thursday. And if you do both of them, your 2 lowest homework assignment grades get replaced with a 100. And this is studying for all the sections for the common assessment on Thursday.
we should always have a class on Wednesday, we still have class on Wednesday?
Some of you are going to be here.
I'm gonna be here tomorrow.
Okay, just send me an email. Okay, everybody good? Paul, I need you on the computer. Everybody else, I need you guys to take out your calculators. I want you to take 2 minutes, because I need to stop talking. I want you to take 2 minutes, read through question number 1 in this handout. Jesus, I'm going to need you to be able to capture both boards, so I don't know if you want to move the camera or just... Actually, most of the action is going to be happening over here. All right. So Karina, could you maybe move to the other spot? Paul, do I need to log into my computer? Is there what? Homework, just put it in graded work. Okay, taking 2 minutes to give it a read. Huh? No, what to do about calculators? Calculators, so question mark. Mark this question up. Think about what you would do on Thursday if you see this question. Probably want to do the work on a separate sheet of paper because I know I didn't give you enough space. Okay, and if I haven't mentioned it yet, the questions that we're going to work on, this was the common assessment 2 years ago. So this is a recent exam. We're doing the whole thing, all the multiple choice, all the free response. All right, here we go. Ruth rode her bicycle on a straight trail. She recorded her velocity v of t in miles per hour for selected values of t over the open interval over the interval 0 less than or equal to t less than or equal to 2.4 hours, as shown in the table above. For that time interval, her velocity is positive. A says, use the data in the table to approximate Ruth's acceleration. At time t equals 1.4 hours, show the computations that lead to your answer, indicate units of measure. I'll tell you right now, this is worth 2 points. Have a quick strategy conversation with the folks around you. What are you going to do? You have velocity information. How do you get acceleration?
The slope. Yeah, the slope. I guess that.
You've got velocity information in the table. What I need is her acceleration at 1.4. I want to get some hands on this. What are you going to do? You see this on Thursday. What's your strategy? One person's got a strategy. Now I'm really starting to worry. 2 people have a strategy. 3, maybe 4. Daisy, what's your strategy going to be?
Find the slope.
You're going to find the slope. Why are you going to find the slope?
Because isn't the chart is for velocity.
Okay, the chart that you've got here is for velocity.
So you find the slope, you get the acceleration.
Okay, right, because one of the things, and I heard this right away from some folks, they thought about that PVA table that we talked about earlier, position, velocity, acceleration. These are all derivative relationships. If I gave you a velocity equation, you'd find the derivative of the velocity and that would get you to acceleration. But I didn't give you the equation. Instead, I gave you data points. So the way that you're going to approximate the acceleration at 1.4 is what Daisy said, we're going to find the slope. But you've got to use the right points here. What are the right points to use, Rebecca?
Would it be 1.2 and 1.6?
You're going to use the 1.2 and the 1.6 because these are the ones that are closest to the 1.4. And your acceleration is going to be approximately your velocity at 1.6 minus the velocity at 1.2 divided by the difference in time of 1.6 minus 1.2. Can we leave that like that?
Yes.
No, yes.
So then you have to put units?
Yes, this is the free response part of the test. And if everything was a number, you could stop here. Not everything is a number. The problem is when you wrote v of 1.6, that is a function that needs to be evaluated at 1.6. Don't leave v of 1.6 and think you're done. What is v of 1.6? It's what, 16.3? Okay, minus what is v at 1.2? 17.2, and we're going to divide by 1.6 minus 1.2. Can we stop here?
Yes.
Absolutely, because now these are all numbers. It's good to stop. If you want to keep going, that's fine, but honestly, you just start to run the risk of making a mistake. And I think this is going to be negative 2.25. Paul, can you check that on the calculator, make sure it didn't just blow it? It is negative 2.25. This answer is no better than this one. This one's no better than this one. I really want you to stop here, and I want you to lock in that point. And now I need the units. What are the units going to be?
Miles per hour squared.
This has to be miles per hour squared, or my other way to say it, miles per hour per hour. And if you're not sure, the numerator, the velocity is miles per hour. The denominator is hours, units for the top divided by units for the bottom. Done. 1 point for this, 1 point for the units. I would expect we're getting both points here. Jackie, you look like you got a question.
You put miles per hour squared, is that?
That's 100% okay, but I know sometimes you guys start to get tripped up and you start canceling out units that aren't supposed to be canceled. Miles per hour, love it. Love it, or miles per hour squared. All right, part B, give it a read, have a strategy conversation. Okay, people that are testing, 15 more minutes. B, using correct units, interpret the meaning of the integral from 0 to 2.4 v of t in the context of the problem. Approximate the integral using a midpoint Riemann sum with 3 subintervals of equal length and values from the table. Have a quick conversation with your partner. What are you going to do here?
The velocity that you consider.
Don't put it in.
We have to write away from
Yeah.
Mario. So Mario is going to take you down to, you know where the deans of instruction are?
No.
Yes, you do. Down College Corner, where you
Okay.
spend a lot of time.
Yes.
Okay, their office, if you go, there's the library on the left, their office is on the right. Okay? They'll take care of you. Okay? Alright, seeing some people off to a good start. First question, what does this mean? Not what's the answer, what's the number, what are you being asked to find here? Just Paul, that worries me a little bit. And we get Jackie and maybe some folks back here. Kevin, talk to me. Integral from 0 to 2.4 v of t dt. What is this? That's not what I'm asking for. In the context of this situation, what does this integral give you? Gerson.
Isn't it the total distance traveled?
It is not the total distance traveled. It's not the total distance traveled. Karina, what is this?
Position.
It's not position either. You're integrating your velocity. Velocity is a measure of how your position changes. Jesus, what is it going to be?
Acceleration.
No.
No, it's also not the acceleration. It is good that we are doing this and bringing to the surface every physics concept ever, except the one I need.
Displacement.
Displacement. This guy here is the displacement. Now be specific. The displacement means change in position from when to when?
From 0 to 2.4.
From t equals 0 to t equals 2.4, and in physics, what are we measured in? What are the units going to have to be? If you're not sure, what are you measuring your velocity in? Miles per hour. What are you measuring time in? Hours. So what are the units? Miles. Okay. Now, for anybody watching at home, somebody earlier said total distance traveled. Who said total distance traveled?
Gerson.
Gerson. You could get away with saying total distance traveled here in this problem because there's something special happening in this problem.
She was in straight line.
The velocity is positive. They tell you your velocity is positive, meaning you're always moving in the same direction. You're always moving forward. So in that case, your displacement and your total distance traveled are the same. You never turn around. You never change your position. All right, now we need to do the approximation. And Kevin, I think this is what you were trying to get to. We're going from 0 to 2.4. We want to figure out our...
3 subintervals.
Right, what did they say? 3 subintervals?
Yes.
Okay, tell me more.
0.8.
3 subintervals.
Using a midpoint.
Midpoint. There's something else that's really important about these 3 subintervals. Sometimes you guys make an assumption that's not true. 3 subintervals of equal width. Now, is it possible to go from 0 to 2.4 and like get a point here and get a point here, and those are not equal in width? Yeah, sometimes they do that, but in this case they say 3 subintervals of equal width, and so this is where we would say, oh, delta x is 2.4 minus 0 divided by 3, which is 0.8. So here's 0, 0.8, and 1.6. If you were using the left endpoint method, then for each subinterval you use the value on the left times the height of the function at that point. Value on the left times the height of the function. Value on the left times the height of the function. Midpoint method. What do we need?
You divide each slice by 2.
Each slice gets cut in half equally, so where's the midpoint here? 0.4. Over here, 1.2, and over here, 2.0. The 0.4, the 1.2, the 2.0, these are the important points that I need. For each subinterval now, you need to tell me 2 things. How wide is the subinterval? And how tall? How wide is the subinterval? 0.8. How tall? What's the height of the rectangle that you would build? And I'm hearing from a lot of folks, 11.8, because that's what this guy is. That's the value of the velocity at your midpoint. So 0.8 times 11.8. Okay, plus the next one. So finish that off. Yeah, calculations there. So it should be 0.8 times 11.8. Your next interval still has that same width of 0.8 times your height at 1.2, what is that, 17.2? Plus your next one is 0.8 times the velocity there is going to be 16.8. Can you stop here?
Yes.
Yes.
Is everything a number?
Yes.
If everything's a number, you can stop and you should stop. I would stop here and you get the point, but if you have the time, you do it on the calculator. Paul, what are we going to get? I think you just missed a plus sign there. Did anybody actually type this into the calculator and get a number?
No.
Not yet. Plus, and according to Paul, 36.640. There's no need to actually do that calculation at the end because everything's a number. All right, part C, for the time interval 0 less than or equal to t, less than or equal to 2.4 hours, Ruth's velocity. Now they're giving me some stuff. Her velocity is given by g of t is equal to 24t plus 5 sine 6t. Oh, Jesus, sorry, I moved on you, didn't I? Divided by t plus 0.7. According to the model, what was Ruth's average velocity during the time interval 0 to 2.4? Now I want average velocity on the time interval 0 to 2.4. Have a quick conversation about that. What are you going to do?
For the last one we just did it, we didn't include the t, but did you get it wrong?
Say that one more time.
We didn't include the t.
Is it if it includes the
Like if we do. Like now we have all that, all the numbers, but we didn't include the t.
Oh, you wait, DT? I'm not seeing DT up there.
Just like when you do the integral.
Oh, don't do that. Don't do that integral from 0 to 2.4 because you're not integrating anymore. Okay, the key word here, average. In calculus class, you find average one way all the time. Average is going to be an integration. You're going to integrate your function from 0 to 2.4. That's not average though.
One over.
Divided by b minus a, so 2.4 minus 0, or times the 1 over 2.4.
Yeah.
G of t, they gave it to you as a function. So hopefully you're typing this in the calculator right now.
Yeah.
You're going to do an integral from 0 to 2.4, and you're going to divide by 2.4 minus 0. We're going to award 1 point for the setup, and then the next point comes, can you get to the number? Do you have the skills to get the number to make that happen?
How do you do to get the integral again? With the short
Yeah, Paul, you need to integrate. You know what, Paul, hold on. Before you retype all this stuff, just arrow up. See if you can do that. Okay, and then select this part here. There you go. And then go menu. Yeah, let's see if that works. Oh, I didn't like that. All right, anybody else get a number? What do we got?
14.06.
14.064? 14.064. Okay, 14.064. What are the units?
Miles per hour.
Miles per hour. Miles per hour squared.
Miles per hour.
Miles per hour. Miles per hour squared again.
Per hour.
What are we finding?
Velocity.
Average velocity. So this is a velocity number. You're saying on average my velocity on this interval is 14.064 miles per hour. That's going to be part C. All right, part D, according to your model in part C, is Ruth's speed increasing or decreasing at time t equals 1.3? Speed increasing, decreasing at t equals 1.3. We've only got a minute left. To figure out are you increasing or decreasing in speed, you need two things.
Acceleration and velocity.
You need the velocity and you need the acceleration. So because the function they gave me is g, I need to find g of 1.3. And then I need to find g prime of 1.3. And Paul, I should have told you to type this in as a function like on the graph. That would have made life a little bit easier. Did anybody actually put it in as a function on the graph? No. Okay, unfortunately that would have made life a little bit easier. But just to wrap this up, if when you finish this off, g of 1.3, let's say g of 1.3 is positive, and g prime of 1.3 is negative, what's the conclusion? Speed is decreasing. Don't say that though. Speed is decreasing because velocity and acceleration have different signs, but we forget the important thing here. When is speed decreasing?
At 1.3.
At t equals 1.3. All right, good enough. Let's turn that off. If